Hello, algebra students. It's time for lesson 5.4b, and this is on a new kind of function called a piecewise function. Basically, you can remember the name because it's kind of broken up into pieces. So, a piecewise function, it's defined by two or more equations, and each piece applies to a different part of its domain. So, it's kind of the x values determine what it's going to look like here. So, graphing a piecewise function. So first off, we have graph y equals, and then we said a piecewise function has two or more equations. These are the two equations. There's negative x minus 4, but only if x is less than 0, and y will equal x if x is greater than or equal to 0. If you don't have a ruler right now, you should hit pause and go grab one, because when we graph this, we're going to need one. Welcome back. Okay, so when you're trying to graph this, we're going to use our knowledge of graphing equations in the form of y equals mx plus b. These are in that form, but how we graph it is determined by what the domain is. And remember, domain are the x values. So when we're graphing y equals negative x minus 4, maybe you want to change that. You would notice that, okay, the b is negative 4, and the slope, remember when you just have a negative x, it means negative 1, and the run would be 1. So I know my m is negative 1 over 1, and my b is negative 4. It says this is only true if x is less than 0. So let's try this. If the b were negative 4, I would normally put a closed circle on the negative 4, and that's my y-intercept. And if my slope is negative 1 over 1, I would go down 1, right 1, down 1, right 1 from that point. This says, though, that x has to be less than 0. If x is less than 0, that means that my x values can't be 0. They can only be less than that. So if x is less than 0, I can't put a closed dot on the negative 4 because that's saying that x is 0. So all we have to do is put an open circle on the negative 4. This is probably sounding familiar to you right now, I'm guessing. All right, let me scooch that up so you can see it. So you should have an open circle on the negative 4 because x cannot be 0. X can only be the values less than 0. That's it. So when you graph this, if my slope is negative x, that's going to mean either down 1, right 1, or up 1, left 1. So if I go down 1, right 1, do you see how I'm now at values where x is greater than 0? I can't do that, so I need to do the reverse and go up 1, left 1 instead to get my other points on this. Now x is allowed to be all of those values, so I'm just going to extend my line in that direction. And that right there is the graph of negative x plus 4 if x is less than 0. Okay, now I want to graph y equals x if x is greater than or equal to 0. So if you just look at the equation y equals x, your slope, remember if there's not a number in front of the x, put a 1 there. Your slope is 1, so that means the run is 1, up 1, right 1. And there's no plus b, so that means my y-intercept is 0. Now, y equals x if x is greater than or equal to 0. So if you want to plot your y-intercept, do you think I should make this opened or closed if x can be greater than or equal to? Hopefully you said closed. If not, by the end of this lesson, I think you'll have it down pat. X is allowed to be 0 or any values greater than that. So I'm going to use a closed circle because it can be equal to it. Just remember that little line underneath closes the circle. If it doesn't have a little line underneath, it's open. Alright, so now I want to graph this when x is greater than or equal to that. So I'm looking to graph just this way because these are these are the values of x that are greater than 0. So from here, I can go up 1, right 1. That's what my slope says to do. And you keep doing that all day long, or just plot a couple of them and draw your line. So this right here is the graph of a piecewise function. There's two pieces to this one because there's two equations. Not only do I ask you to graph it, I ask you to describe the domain and describe the range. This is all considered one big graph. So for domain, I'm going to write it like I should, except I always make those all messed up. Sorry. Okay. When you give me the domain of this, you're telling me all the different values that x can be. So as you look here, this line would continue on. Basically, x can be anything this way and anything this way. And there's a closed circle here and there's an open circle here. X can be 0 if you put both of these graphs together, and that's what we're doing. So if you look, because these lines are both extending in this direction and the zeros included, can't the domain be anything? It can be any number. This is not discrete data. This is continuous. There's a line here. So x can be any real number. So you can either write, for the domain, you can write all real numbers, or you can use a fancy little symbol to represent that. It's kind of like when you make the paragraph sign, you have the two lines with a P. So there's a line, R. This means all reals. Maybe just write it this one time. So when you look back to your notes, you know. So the domain can be anything. As far as the range goes, I want to look at what are all the values that y can be. So we start at the bottom of the graph, remember, because I want to go from low to high. And y can't be -4, but y can be any value that's greater than -4, right? So for my range, I would write y is greater than -4. Remember, when you have that continuous data, we end up summing it up that way instead of giving those specific little individual values. All right, let's try one more, because generally just one isn't enough. Okay, so for this next one, the pieces to this, y equals -2 if x is less than or equal to 0, and y equals x if x is greater than 0. I didn't forget to put the x next to the -2. Y just equals -2. So when you see y just equals -2, I'm hoping that you think, oh wait, there's no slope. That means it's horizontal, because horizontal lines don't have a slope. So if y equals -2, that means my y-intercept is -2, and it's just a horizontal line that goes all the way through it in general. But this one, I'm told that y equals -2 if x is less than or equal to 0. So on this -2, since x can be less than or equal to, I'm going to put a closed dot. And I only want to graph the values when x is less than or equal to 0. So your line should only be going to the left. Try to make it dark because it's right on the line. Hopefully you can see that. All right. The other equation we have is y equals x if x is greater than 0. So with this one, there's no b. That means b is 0. And my slope would be 1 over 1. So x can be greater than 0. X can't be 0. Can only be greater than 0 when y equals x. So I'm going to use an open circle on the 0. And if my slope is 1 over 1, I'm supposed to go up 1, right 1. Let's make sure I want to graph in that direction. Yep, I only want when x is greater than 0. So I only want my line to go this way. So I'll do my slope up 1, right 1, up 1, right 1. We'll draw our line. And there we have it. So when we find the domain and the range of this, we put all the pieces together. For our domain, when I'm looking at what the different x values can be, there's an arrow going off this way and an arrow going off this way. And I see that there's a closed and an open, so this one kind of makes it so that x can be 0. So can't x be anything? Yep. So all real numbers for my domain. And for my range, let's see. Y can be, well, y can be -2. I see that. Can y be -1? Or any value in between here? It can't. So I can't just say y is greater than or equal to -2 because it doesn't fit those pieces there. So I'm going to have a couple things here. Y can be -2, so y equals -2. Or, for this one, here's 0. Can y be 0? Nope, it's not filled in, it's open. But can't y be anything greater than 0? So to show that y can be anything greater than 0, I would write y is greater than 0. Alright, so basically when you're trying to graph the piecewise, you just graph each piece, but you have to pay attention to what the domain is so you know which way your line should extend and if you should use open or closed circles. It does make a difference. Alright, now what I want you to be able to do is to look at a graph of a piecewise function and be able to write me the equations that go with it. So basically, you're just writing linear equations, but we have to also list domains in there because that's what makes it piecewise, is that the domains differ. So let's start with this little piece right here. Why not? The very first thing you should do is just try to write the equation of the line, and then we'll fill in what the domain is later on. So we see these are straight lines, and to write an equation of a line, all you need is a slope and a y-intercept, right? So in this equation right here, the y-intercept is 3. So I'm just going to say, okay, b equals 3. I'm going to just write that over here. And now we have to find the slope. And I know I didn't put little dots on there for you because they're not always there. But this whole line is made up of an infinite number of little teeny tiny dots. I like to use the dots that line up perfectly where the x and the y's cross. So I probably wouldn't pick this to find my slope. But as I look through, I see it crosses here, it crosses here, it crosses here. So you could pick any one of those to highlight. So on this one, to get from one point to the next, choose any 2 points you want. So let's say I want to go from here to here, or here to here you might do. You have to go up 1, right 1. If I chose to go from here to here, I would go up 2, right 2. From here to here, I go up 3, right 3. No matter what, 3 over 3, 2 over 2, 1 over 1, they all simplify to 1. That means my slope is 1. So the equation for this little line right here should be y equals x plus 3. Hopefully you're with me on that. So y equals x plus 3. Or you could say f of x equals x plus 3 and use function notation. Alright, let's try this one anyhow. Alright, I need my b. So on this line here, let's see if you can see that. No, there we go. The y-intercept is -1. Now I need my slope. So it looks like this is where they cross perfectly and there as well. So I can choose any one of those. But to get from here to here, I go up 2, right 1, up 2, right 1, up 2, right 1. So if you're going up 2 and right 1, that means your slope simplifies to 2. So the equation for this line will be y equals 2x minus 1, or 2x plus -1. So right now we're almost there. We can say y equals, and we're going to have our x plus 3, or 2x plus -1. So far so good. And now we have to put those domains with it. Alright, so y equals x plus 3 when what? So, or if. So in this equation here, can x be 3? I'm sorry, can x be 0? Because this is the x, that's a y. X can't be. X can only be values that are less than 0. So I would say y equals x plus 3 if x is less than 0. For this equation here, x can be 0. That dot's closed. And x can also be values that are greater than 0. So y equals 2x plus -1 if x is greater than or equal to 0. That's that. Piece of cake, right? I know. It's a process. Alright, let's do one more of these. If you want, you could pause it and try to write one on your own and see what happens. Use a pencil. That way if we make mistakes, we can just erase them like they never happened. Okay, so take a look. Let's write an equation for each line to start. So let me scooch this up a little bit. I'm going to start with this one. When I look at this one, it looks like the y-intercept happens right here at -1. So this graph crosses the y-axis at -1. That's my b. To find the slope, I just need to pick 2 points. So maybe I'll go from here to here. You could go from here to here, from here to here. Just look for a spot where it'll be a nice whole number amount. I wouldn't pick the values in between. So to get from this point to this point, you go up 2, left 2. or I can even go from here to here and say up 1, left 1. This is a decreasing line right here. So if I'm going up 1, left 1, 1 over -1 would simplify to -1. So my slope of this line is a -1. That means my equation for this line is going to be y equals -x minus 1, or -x plus -1. Remember, you don't need to write the 1 in front of the x. It's implied. So that's this equation right here. Now let's take a look at this equation. For the y-intercept, oh my goodness, what do? I don't see it anywhere. We can still find it. Let's find the slope first, though. That's what I would do in this case. I would find the slope because you can always extend the slope in the opposite direction to figure out what the y-intercept is. So in this one, the slope looks like it crosses right here perfectly. Up 1, right 2. So the slope of this one is 1/2. So the opposite of going up 1, right 2 would be to go down 1, left 2. And if you do that, we see that the b would be at -2. That wasn't too bad, right? Probably got all nervous when that line didn't cross. It doesn't mean it doesn't have a y-intercept. Okay, so now we need to write our little equation. So I'm going to say y equals, and let's list our equations out. We have -x plus -1, and we also have 1/2 x plus -2. But we need to list the domains with that. That's what makes it piecewise. So y equals -x plus -1 when? So let's look at our x values. It looks like there is a closed circle when x is 2. So x can be 2, and x can also be all the values that are less than 2. So I would say if x is less than or equal to 2. When I have 1/2 x plus -2, it looks like there's an open circle on the 2. So x can't be 2, but it can be all the values that are greater than 2. So for this one, I would say if x is greater than 2. And we're done with that one. We have one more, of course, because where would we be without a nice little story problem? March's reading one, math story time. Okay, this is called a step function. It looks like a piecewise. So it's a piecewise function defined by a constant values over its domain. The graph of a step function consists of a series of line segments. The graph of a step function can look kind of like a staircase. So if it looks like steps, it's a step function. How are you ever going to remember that one? I know, it's crazy. So if it's pieces, it's piecewise, and if it looks like step, it's steps. So here's an example. A store charges $3 to rent a DVD for 1 day and $2 for each additional day. Write and graph a step function that represents the relationship between the number of days x and the total cost of renting the DVD for up to 5 days. So I want to do this for 5 days, and we have to kind of figure out, okay, what are we supposed to label on here? So the variables we're dealing with are the days and the cost, right? So days would be the independent. I'm going to write that down here. And the cost would be my dependent. So I'll write that over there. And it's in dollars, so I'll write a little dollar sign there. Lovely. And it says that I want the total cost for renting the DVD up to 5 days. So that means we're defining our domain. I only want to go up to 5 days. So 0, 1, 2, 3, 4, 5, and that's my x. Okay. Now, if it charges $3 to rent a DVD for the first day and $2 for each additional day, I'm seeing that constant rate as 2. So I would do my number scale as a 2, not a 3. Because 3 is my starting point, but 2 is what it's going to end up going up by each day. That's just me. So on my y-axis, I would say 2, 4, 6, 8, 10, and this is my y. Okay. So can you rent a movie for half of a day and pay less? I'm sure you've rented movies before, and you know you can't do that. You can't rent a movie for half of a day. So that kind of should help us out with seeing that I can't just make a nice solid little line here. This isn't continuous data that I'm dealing with. So let's graph some of these things. Think about it. So if the store charges $3 to rent a DVD for 1 day, That means on our first day, we're going to pay $3, right? So my amount for the first day can be $3 here. And that's after one full day of watching it. Can you have a movie at home for half of a day? Yeah, you can. Is it possible to rent a movie for 0 days? No. So this is where it gets kind of strange. I can have the movie for anything more than 0. So between 0 and 1 day, it costs me $3. I'm going to make an open circle here at the 3 and connect these. And this shows between 0 and 1 days that I'm going to pay $3. Okay? Now, it's $2 for each additional day, right? So if I have this movie for 2 days total, I'm going to end up paying the $3 for the first day and the $2 for the second. So now I'm at $5. So for 2 days, I would pay $5. Alright, so we have time between 1 and 2 days. I can have that movie for 1.5 days. If I have the movie for 1.5 days, aren't I still going to end up having to pay the $5? Yes. But if I have this movie for 1 day, I only pay $3, right? But I want my time to start just beyond the 1. So you can make an open circle on the 5, and we'll draw our little line to show that if I have this movie for more than 1 day, but up to 2, I'm going to pay $5. If I have the movie for 3 days, I'll pay the $3, then another 2, then another 2. So if I have a movie for 3 days, I would spend $7 on it. If I have the movie for 2 days, it's 5, but anything more than 2 days, between the 2 and the 3, will be 7. I'm hoping this is making sense as we go. Alright, if you have the movie for 4 days, because we do have to keep going because I asked for up to 5. Well, the math story did. If you have the movie for 4 days, you're going to pay $3, $4, $5, $6, $7, $9. You should just buy the movie. So I will pay $9. If I have it for 3 days, it's still 7. But anything more than 3 days would be the 9. So between 3 and 4 days, that's where I'm spending the $9. And the last one, it's $11. So if you have the movie for 5 days, again, we're going up by 2, this was 9, you end up paying $11. Anything more than 4, between 4 and 5, is 11. And this is why it's called a step function, because it looks like you can just walk right on up. And hopefully you just walk right on up to Target and go buy the movie, because if you're going to have a movie for 5 days and pay $11, you might as well pay $14.99 and have the whole thing forever. See you tomorrow.